Hello everyone. Today we will going to see a application based PPT on digital image processing, and the application is majorly we see in many products, that is image restoration. That is the one of the basic application of digital image processing, and we are thankful to present you this presentation. We are a group of two members, Shivam and myself, Sumit. So let's move next. So what is the image restoration? Image restoration, you can see this image that the pigeon is in a blurred image, restored in a very portrait image. That is nothing but the image restoration. Image restoration is when you restore the image from the degrade form. So image restoration attempts to restore image that have been degraded. I told you that the image is degrade and we save or restore it back into its normal form. That is nothing but the image restoration. Here is another example of image restoration. It is almost similar to image enhancement, but more objective. So we will see here what is image restoration versus what is image enhancement. Image restoration assumes a degradation model of that is known or can be estimated. Original content and quality does not mean good looking appearance. Image enhancement is subjective, whereas image restoration is objective process. Image restoration tried to recover original image from degrade with prior knowledge of degradation process. Restoration involves modeling of degradation and apply the inverse process in order to recover the original image. Although the restored image is not the original image, it's approximation of actual image. So what we understand from this sentences, the restoration of image and versus enhancement, it is similar process, but what happen in restoration, the restoration image is not the original image, but it is the projection. It is almost the original image. It is the projection, we can say, but it when we restore the image, we go almost in a reverse direction. We apply it to degrade it. So we did not get the actual image, but we get the projected image, which is actual projection of the original image, but not original image. And if we try to restore the image, we do need the knowledge of degradation. Without the knowledge of degradation, we can't restore the image. So here we are not going to discuss the degradation method, but only restoration techniques we are going to discuss here. So here is the degradation model. I have embedded a degradation model here, so you can understand the actual process behind the degradation. So we restore the images for it. So what is the objective for degradation? To restore a degraded or distorted image to its original content and quality. That is the main objective for the restoration. So here you can say the image function of xy get into the degradation function. After degradation function, it has some noisy content inside it. So that is nothing but the degrade image or distorted image. It's a mixture of various signals. So that's why the quality and the resolution gets poor. After that, there is suppose n xy, it's suppose noise, we can say noise, it get mixed in. So and the output image, it is g of xy, it is the pure degrade image. If you want to restore it, you have to pass that image through restoration filters, and you get f uh, mark xy image. What mark mean here, that the output of restoration image, it's not the original image. I am repeating that the output of restoration image is not the original image, it is the projection, or it is very close to the original image, it still has some noise. So here is some formula for spatial domain and frequency domain, and the matrix also, you can read it. So next, so noise model and their PDF. Noise model, what is noise model? Here we can see n of xy. This is nothing but noise model. We are inserting it or present inside the degraded image. So there are different noise model for the image. Like
Gaussian noise, most common channel. If you send any image or transmit any image through the environment, the Gaussian noise is most common noise which involves inside the image. So you have to restore always when you receive image. You can there is a major common example for the Gaussian noise. You say you send WhatsApp images, WhatsApp to WhatsApp, these messages are encrypted, but still the quality gets poor, and that's some common example of Gaussian noise. The another is uh, relay high, Erlang and gamma noise, exponential, uniform or impulse, salt and pepper noise. So most Gaussian and this impulse noise is also most common noise. So we have an application implemented in MATLAB for the salt and pepper noise by using some restoration filters. We will see that later. So we will see that later. Here you can see the various type of noise waveforms that actually causes for the poor quality of image. So there are several techniques for restore the image, degrade image. I have mentioned here few. Inverse filtering. There is a technique inverse filtering, minimum mean square errors. Wiener filtering, we have also an application, we have actually applied that filter to remove the pepper salt noise. Constraint least square filtering, non-linear filtering, advanced restoration techniques are there also. So filter used for restoration process, so which filters we use for the restoration process? There are mean filter, there are order static filters and adaptive filters. We have application of order static filter. So what are the mean filters? That are arithmetic mean filters, geometric mean filters, harmonic mean filters and contra harmonic mean filters. In order static filters there are median filters, max and minimum filters, midpoint filters, alpha transmitted filters, and in adaptive filters there are adaptive local noise reduction filter, adaptive median filter. So I will just explain what are these filters. Arithmetic mean filter means they remove arithmetic noise inside them. Geometric mean filter means they remove geometric noise inside them. Harmonic filter, they remove harmonics inside the pictures or images which get blurred. That's my first, second, third harmonic. It can be contra harmonic median filter mean it is similar to harmonic median filter, but some extra part. Median filter max, we will see the application directly. Filter to remove noise. Use special or different kind of remove different kind of noise. Arithmetic, here is formula for the final image, restored image, that is 1 upon mn summation of g of st, where g of st is the degrade image here. This is implemented as simple smoothing filter blurs to image to remove noise. Here is geometric filter. The formula for geometric filter achieves similar smoothing to arithmetic mean but tends to lose less image details. So here understand the geometric mean filter is not sufficient. What we can say is not that much gives better image to you as the arithmetic mean, but it's gives similar. Also it lose some contents in the image. Contra harmonic filter. Q is the order of filter and adjusting its value changes the filter's behavior. Positive value of Q eliminate paper noise and negative value of Q eliminate salt noise. So here is the application to remove salt and paper noise. We can use a contra harmonic mean filter to remove salt and paper noise. Here is what the Q is, Q of the order of the filter. Order of the filter mean how many times you have to filter, like you filter one times the image restores somehow better, you filter two times the image restore another how somehow better than the previous one, and it's get better but not up to the original image. You have to remember that the original image is not we are getting back as output. Order static filter. So special filters are based on ordering the pixel value that make the neighborhood operated on by the filter. What is the pixel value here? What does it mean? Like if there is a blur image we have to restore, these filters works on the pixel restoration. Like they change the pixel value, they update them to the high definition value, we can say, and automatically each pixel get updated simultaneously, and the image gets smooth. The median filter, these are the some formulas or for functions, so you can read it out. Max filter, min filter also good for paper noise, and min filter is good for salt noise. If you want to remove it separately, you can go for max noise or min noise. Alpha trimmed min filter. So the conclusion for the this technique of or application we have discussed here, that to restore the original image from degrade image, if you have clue about degradation function, it's called image restoration. Okay, if you have clue how the image get degraded, then you will able to restore the image. Like if you know what kind of noise inside the image, then if you are easily able to restore the image. Otherwise you have to apply every filter and pass this image to every filter and they see output and choose the better one. That's the normal process. If you don't need to degrade how it get degrade. The main objective should be estimate the degradation function. If you are able to estimate the h, what is degradation function, then follow the inverse of degradation process of an image. Whether spatial or frequency domain, spatial domain techniques are particularly used for removing random noise. Frequency domain techniques are particularly for removing periodic noise. So application of this DIP application, it is the DIP. Okay, image restoration is image processing application, and image restoration have particular application for it. So it can use for many softwares also, like identification of something, computer vision or robotics vision. You can go for like there are some projects where we have to find what the actual object is. So these sensors are inside the computer or robot, and so the robot sometimes gets a blurry image. So there is an application to restore the image. Then steganography, image enhancement, image analysis in medical, like a heart, you can say in X-ray, in sonography, morphological image analysis, space image analysis, and bottling and IC indexes. That's so there are some popular softwares which you can apply actual image restoration process inside it. The CVIP tools, computer vision and image processing tools, Intel Open Computer Vision Library, Microsoft Vision SDL Library, MATLAB, and KHOROS course, we can say. So here we apply a MATLAB code on image filtering, image restoration using a median filter to remove paper salt noise. So you can read the code. First we take noisy image, then plot the image for the output purpose to understand. Plot the image, so we apply a median filter 1, median filter 2, and then we calculate the PSNR of a noise image, and then calculate the PSNR of noise P image when it get passed from first filter. We calculate PSNR 2 for noise free image when it get passed for median 2 filter, and here is the output. You can say this is the noisy image. This and these images are both same. I actually what you can say, it actually get doubled for me. I'm sorry for that. And this is the final image of restoring after restoring. So here you can see how much difference you get from this applying these filters. So that's why the image restoration is we can say a common application. You can see in every time, you can see everywhere. Thank you so much for listening.